Find the area enclosed by the graphs of this linear function and this quadratic. And what's going to help is actually draw a picture. Now, because this has been shifted to the right 2 units, and this is a negative linear, I'm expecting that this whole thing to be in the first quadrant. So I'm just going to kind of zoom in on that. And this one goes up to 4 and then goes down. This one only is going to go let's go 1, 2, 3, 4. It's going to go up from here. See, 1, 2, 3, 4. I go over 1, up 1, over 1, up 1. That's just the basic shape of a quadratic, right? You plug in 1 into there, you get 1 minus 2 is negative 1 squared is 1. So the same thing is true there. And you're going to go over 2, so it's going to be 0. 0 minus 2 is going to be negative 2. Squared is 4. So it's going to hit that point. The same thing is true for 4. Plug 4 into there, you're going to get positive 4. So this is what the quadratic function looks like. And the linear function is 4 minus x. That means the y-intercept is 4. It's going to go down 1 over 1, down 1 over 1, down 1 over 1. It's going to cross it right there. So this is the area enclosed by these 2 graphs, this portion right here. And you can see that goes from an x of 0 up to an x of 3. And the highest point, right? The highest point is the 4 minus x function. So really we're asking, what's this height across this entire thing? We're going to be, take the interval from 0 to 3 of the top portion of the height, right? Which is 4 minus x. That's the highest point. And the lowest point, so we're going to subtract, that's how you find distance, or that vertical line, from the lowest point, which is x minus 2 squared, and dx. Of course, this is going to be easier to not do it like this, but instead expand that polynomial out and simplify. So we're going to get x squared. It's going to be minus 4x plus 4. And then distribute the negative. So we're going to get a plus and then a minus here. And then we can simplify the statement down. Let's see, 4 minus 4 cancels. And then we have negative x squared plus 3x dx, which of course is much easier to solve. So using the fundamental theorem of calculus, we're going to get, let's say it's going to be negative 1/3 x to the 3 plus 3 halves x squared evaluated at 0 and 3. Of course, when you plug 0 into there, you get just 0. So really, it's just plugging 3 into there. 3 cubed is 27, divided by 3 is 9, so we get negative 9 plus 3 squared is 9 times 3 is 27 over 2. So we get 27 over 2. This, of course, is going to be 18 over 2. So we're going to get, it's going to be 9 over 2. A.